We're studying IGCSE Chemistry and we're revising Reversible Reactions and Equilibria. This is the second class in the series. In the last class, to recap, we studied quite a few things, such as we looked at, let's say, types of reactions, why something is reversible. We looked at color change and all of that, let's see. So we looked at reversible reactions first. That reactions are which can go backward or forward. They can go backward or forwards based on the conditions. Now, Manvi, have you written next part? Anas, have you written this? Do you remember?
Yeah, I remember this.
Yes, I remember now.
Fine. Reversible reaction can go forward or backwards based on the conditions. So NaCl always goes backwards. But ammonia can go forward or backward. Now this forward, NaCl plus chlorine, that makes salt, Na plus Cl, that is not a reversible reaction because it only goes in one direction. But the reaction of nitrogen with hydrogen, N2 plus 3H2 gives us 2 NH3, that goes in both directions. Therefore, it's a reversible reaction. So 1 mark in the exam, what are reversible reactions? Now we look at what is the meaning of equilibrium. That's always 2 marks and it will be guaranteed to be asked. So that's 2 marks. Now, test for water, we looked at how anhydrous turns hydrated, how the color changes from white to blue. And our cobalt chloride solid is anhydrous salt is blue, and the hydrated salt with water of crystallization is pink. Next, we did some questions. I asked you how we answer it. The first example was it goes forward if I add water, and if I heat it, it will go backwards to removing water. Now we looked at the factors affecting shift in equilibrium. The 3 factors are, Anas, read from here.
The 3 factors are factors affect shifting in equilibrium, concentration, temperature, and pressure.
Okay, concentration, temperature, and pressure. Fine. Now, next thing. First, we start with concentration. And I gave you the rules here. Right? You have this example and the rules. So, if you reduce the concentration of the reactants, then the equilibrium will shift, favors the yield of the products according to Le Chatelier's principle. Equilibrium shifts forwards. Now, Manvi, read this rule quickly. Rule 1.
Reducing concentration of reactants favors yield of reactants. So according to the Le Chatelier's principle, equilibrium shifts backwards or forwards, whatever.
Not or forwards, backwards.
Backwards, yeah.
Fine. Now, Anas, read it again. Reducing concentration of reactant products. Read the product one now. What happens?
Okay. Reducing concentration of products favors yield of products. So according to Le Chatelier's principle, equilibrium shifts
forwards. Now we know it's forwards because, well, the products are on the forward side or the right side always. You can write right or forward. The left side is the backward side or the reactant side. This is left or back, which is reactant, and this is the reactants. And the forward one is products, which is also the right side. They can use any of these words in the exam. They can say product side, right side, forward side, all means the same. Backwards, reactants, left mean the same thing. Next, second rule. Manvi, read it out loud. Second rule.
Second rule. Increasing the concentration of products favors yield of products. So according to Le Chatelier's principle, equilibrium shifts forwards.
Right, so reactant with the product. If you increase the concentration of reactant, then products will be formed like this. And the equilibrium goes forwards. Now, Anas, read the second one for products.
Okay, increasing concentration of reactants of products favors yield of reactants. So according to Le Chatelier's principle, equilibrium shifts backwards.
Backwards, perfect. Now you understand how I wrote the rule. Now temperature. This is where we stopped, I think. Okay. Now, have you written these rules? Start the class. Let's start the class here from temperature. I think you have, right? Manvi, checking your notebook. Anas, check. If you have not written, then there's no way you can get good marks in the exam.
We
You
have
to write
written
all
all
of
this. We have
Okay.
written this.
Anas, you too? Anas, if you haven't written, you'll have to write it later, or perhaps even right now. So tell me if you have written or not.
Okay, okay.
Written?
No, I'm writing.
Let's see. Writing now. Okay, then don't write it now. Take a screenshot. Fine. Or write it now. No worries. Write it. Write it quickly. I want you to write the example as well. So this is the example. N2 plus 3H2 gives us this. The rules are given. Manvi, read the question. Anas, write. Manvi, read the question.
Yeah. The reaction system is put in cold water. What happens to the equilibrium? Explain. Equilibrium
Explain, okay.
shifts towards the exothermic reaction because equilibrium changes to oppose the change.
Right? Oppose the change. Now we don't have to write that. We know it is going to oppose the change. That's correct. But if you can just mention Le Chatelet's principle, that will be enough. All right. Now we know that the Le Chatelet principle means that you are basically opposing a change. What is Le Chatelet's principle? Haven't I given it to you? I think I have. Let's see.
Yeah,
Le
you
Chatelet's
have.
principle.
Uh,
Where is it?
1 second. I'm finding it in my notebook.
Then
Uh,
yes,
one-
right here. If conditions of an equilibrium are changed, the position of equilibrium moves to oppose change.
Yeah.
Clear? That's Le Chatelet is a French chemist, born in
Position.
1800s. He died in 1880.
Are we supposed to know this? No, right?
No, not at all. No, it's general knowledge.
Yeah.
Now, okay. So now in this case, what we have to do is, let's do over here. Let's see. Now the reaction system is put in cold water. What happens to equilibrium? Explain. Let's see. Now you gave me the answer, but we have to write it in two. It's 2 marks, so 2 points. And always, Manvi, in the exam, I want you to have bullet points. Don't write a paragraph. Is that clear? Because
Yes.
it's much harder to get marks if you write a paragraph. So 2 marks, we get 3 points. Fine. Let's start with this first point. Okay, it's put in cold water. First thing we need to say, what is the reaction? That's how we start. Reaction is exothermic. Okay, done. That's the 1 mark. Or let's say exothermic. So yield, equilibrium. Let's say equilibrium shifts to forward side. Okay, we don't say shifts to exothermic side, Manvi. Why? Because we have to tell the
Okay.
we have to
But,
tell the examiner which side is exothermic, right?
But
Because
if
examiner
they're
won't
not
know.
giving us, but if they won't give us an equation or something to base this off, if it's a general question
That will never be a general question. It will always be with an equation given to you,
with
right?
context, yeah.
Yeah, never a general question. The equilibrium shifts. Okay, not shifts to forward side. All right. According to Le Chatelet's principle, to favor yield of products. According to Le Chatelet's principle. Now these are your 3 marks. 1 mark, 2nd mark, and 3rd mark here. But you won't get a 3rd mark because this is very common. So it's good to write this, but the marks are only for this. Sometimes you may get marks for this. So keep it in, but not always. Some questions are 3 marks. If there are 3 marks, then they'll give you marks for this. But if it's 2 marks, then these are the only marks. So as a good habit, we'll just keep the Le Chatelet in there always. Fine. Now, Anas, read the answer and read the question. First, read the question quickly.
Okay. Reaction is exothermic. Equilibrium shifts to forward side to favor yield of products according to Le Chatelier's principle.
All right. So basically, reaction, or let's say forward reaction, is, we don't just say reaction, we say forward reaction. Forward reaction is exothermic. That's the key word as well. So forward reaction is exothermic. Equilibrium shifts to forward side to favor yield of products according to Chatelier's principle. Fine. The next thing we look at is called pressure. It's quite easy. We have done concentration, yes? Yeah, that was the first thing. We did temperature. Now we look at pressure. Rule 1. Write the rules. First rule is, there's only one rule actually. There's no other rule. The only rule is, when, let's say, if pressure increased, equilibrium favors yield of side with least number of particles. Let's say lower number of particles. Fine. Any questions?
No.
Write this quickly. Tell me when you're done.
Yeah.
According to Le Chatelier's principle. The pressure is increased, equilibrium favors yield of reaction side with lower number of particles. That's it. You need to memorize it. Let's remove this part from here, and which increased yield favors yield. That's it. Yeah. If you can memorize this, you're getting all the marks. There's nothing else here. Let's look at questions. Perhaps let's try an example. An example of, let's say, SO3 plus O2 gives us 2SO3. Fine. That's a very common reaction which you will be asked always. This reaction is from the contact process, which we'll look at in a second. Now, this reaction is
Contact
also,
process comes under what chapter? Inorganic chemistry or?
it's inorganic chemistry in this chapter, equilibria, reversible reactions. Fine.
Okay, yeah.
Now, let's see. Fine. So the question will be, let's say, pressure is increased. I'll give you one more rule for this, actually. But it's exactly the same. Let's increase slash decrease. Lower slash higher. Now, does that read this actually? Does this make sense to you, Manvik? How will you read this? Now, read it for the reason if pressure is increased.
If pressure is increased, equilibrium favors yield of reaction site with lower number of particles.
Perfect. Anas, read it for if pressure decreases, what happens?
Okay. If pressure decreases, equilibrium favors yield of reaction side with higher number.
Exactly. That's the rule. Now, I can write it in two separate lines, but the only thing changing is that if pressure decreases, the opposite happens. So let's say pressure is increased. Okay, pressure is increased. What happens to, let's say, yield of SO3? Answer. Let's say what happens to
SO3. Okay, it
Yes.
increases.
Equilibrium and yield of. Explain.
Equilibrium shifts towards the forward shifts to favor the forward reaction, and yield of SO3 will increase because when pressure is
Let's do one
increased.
thing, Manvi. Write it in the
Okay.
chart or write it in your notebook actually. Write the question and write the answer in your notebook. And send me a picture. I'll analyze it. Fine?
Okay, yeah.
Because what I want you to do is there are a few words which I want to be there in the perfect order. Fine? Because we need an answer which will always be correct. In every situation, let's have a clear format. I don't want you to think in the exam at all. All you have to do in the exam is look at the question, write the answer, no thinking allowed. That means that will be prepared for every type of question with a clear format. Now, okay, so pressure, concentration, all of that is done. Now, the next thing is Le Chatelier's principle is done. Next thing is iron. Manvi done?
1 second, I'm writing it and then I'll send it.
So the only thing remaining now is we have done color changing, we have done test of water, we have done factors. Next thing is contact process, Haber process, and let's say uses of sulfuric acid, sulfur trioxide, etc. And what else is remaining? I think we have, that's it. 3 things.
Done. I sent it.
Okay, let's see. Now pressure is increased. What will happen to the equilibrium and yield of SO3? Yield is increased. Always write the equation here. Again, I think we missed something here. Did I? Okay, yeah, this has to be a reversible reaction. SO3. Fine. Now yield is increased. Equilibrium favors forward reaction. Okay. According to Le Chatelier's principle, increase in pressure favors the yield of reaction with lower number of particles. Perfect. Now, okay. Yeah, that's correct. Fine. Now, okay. That's fine. That's fine. Now, if I had to rewrite it, I would just do one thing. I'd first say forward reaction has lower number of particles. I would say this separately. Because Manvi, in your answer, you haven't said this. So we'll just say, well, you have to clearly state which side has lower number of particles, and we'll say this forward reaction has lower number of particles. Second, so equilibrium, then we'll say according to the Chatelier's principle, exactly the same thing. Equilibrium shifts forward to favor yield of SO3. Fine, that's correct. Now, nothing much has to be changed. It's correct. Now, why don't we just read this out loud once?
Okay. Forward reaction has lower number of particles. According to Le Chatelier's principle, equilibrium shifts to forward to favor either side with lower number of particles, which is formation of SO3.
So SO3 is forming. So formation of SO3 is favored, and the yield is also favored. You can also write the final point is yield increases. Done. That's it. Let's move on. Next thing is, let's start the Haber process. Now just give me 1 second. Let's see. Now let's look at the Haber process, the contact process first, all right? And I want you to start writing from here. Right, start writing.
We write all of this down.
Yes, you have to write it all. Give the title contact process, then write uses of sulfur dioxide, sources of sulfur. Quick.
Yeah, 1 second.
Now do one thing, both of you, can you take a screenshot of this and take a screenshot first, then start writing.
All right.
Tell me when you're done writing.
Yeah, 1 second. I'm starting. Can you zoom? Can you scroll up once? Okay, yeah. You can scroll down now if you want.
Now these are not the notes I was trying to teach you today, and it's actually taking me a lot of time to find them because there's a lot of classes and the class notes are here. So let's start writing this first. Write this down as well, and I'll show you the proper notes in a second. Anas, screenshot taken?
Yeah, I'm writing.
Okay.
Contact process is basically sulfuric acid is H2SO4, right?
Yes.
So how is that? And contact process turns SO2.
Good. Thanks for reminding. Now, contact process. We look at the main equation here, which is a reversible equation, reversible reaction. Why? Because it has this symbol for the reversible reaction. It can go forward or backward based on the conditions. Now, since I want to form SO3, that's my goal. I'll change the conditions in such a way that only the forward reaction happens. I don't want it to go backwards. I only want it to go forward. So I'll have to change the condition in such a way to make that happen. The conditions are, and let's read the conditions for the contact process from here.
Okay. The conditions are temperature should be 1 second.
Louder. Can we read?
Conditions,
Yeah.
temperature 450 degrees Celsius, pressure 2 atmospheres, catalyst vanadium 5 oxide, source of reactant sulfur, burning sulfur or roasting sulfur sulfide ores, oxygen, air.
Let's stop, not all of that. We have to look at the conditions first. Now, conditions are 450 degrees Celsius, pressure needed is 2 atmospheres, and the catalyst is vanadium 5 oxide. Now, the catalyst does not really have effect on the equilibrium. I've told you that already, have I? Now, in your notes, I want you to write this part here. Effect of catalyst. Now, you have to write this where you wrote just below temperature and pressure. Right before the whole contact process thing, write this. Effect of catalyst on equilibrium. And all you need to write is no effect. But speeds reaction, speeds up reaction. No effect on equilibrium, but speeds up reaction. Tell me when you're done writing.
Yeah,
this.
1 second.
I have to write it before the contact process thing, along with the pressure question.
Okay, done.
Done. All right. Now let's continue. Focus on the contact process. Fine. We have the conditions. Fine. The only thing to change affecting the equilibrium is the temperature, pressure, and the concentration. Now we don't have concentration. We can't change that easily, but we can change the temperature and the pressure. That's on us. How do we change the temperature and pressure? So we increase the temperature to 450. Fine. And we decrease the pressure to 2 atmospheres. Those are the conditions. Now, both Anas, Manvi, have you written this?
Yeah.
Yes.
Now let's look at all. You have to write all of this as well. Anas, start reading from source of reactants.
Okay. Source of reactants: sulfur, burning sulfur or roasting sulfur ores, oxygen, air. Step 1:
Oxygen comes
converting
from air, and sulfur comes from burning sulfur or roasting sulfide ores. That's how it comes. Next thing.
So wait,
What's
sulfur
yeah.
and sulfur are the same thing?
Sulfur and sulfur, say that again.
Wait, what is sulfur and what is sulfur?
Sulfide?
No, sulfur with the F and the P.
Oh, they're the same thing. They're the same thing. Now, they're exactly the same. It's just the spelling. You can write it as F or PH. Both are fine. But how do you get sulfur for this reaction? You have to get it by burning. This right here is not sulfur, it's sulfur dioxide. Or SUFER dioxide. Now write this in your notebook, tell me when you're done. So the source of sulfur dioxide is burning sulfur or roasting sulfide ores, and oxygen is from the air. Any questions?
No.
No.
Fine. So sulfur dioxide, and burning sulfur. Any questions? Add one more point here, burning sulfur in air.
Yeah.
It's not a big difference, but now the small things are what will make a difference between you getting full marks in the exam and getting an A star. Everyone gets A stars, but full marks is the big thing, right? Now, we have 4 stages to this. Write all of it, and when you're done, I'll explain them to you.
I'm done writing.
Done everything, these stages as well?
Yeah, everything.
Okay, Anas, how much have you written?
Wait, I'm at stage 2.
Okay. Now, this on the screen, you have everything they can ever ask you first, the contact process. There are a few more things below, but if you can memorize this, you can answer every question of the contact process. I don't want to spend more time on revising and teaching. I want to spend more time on practicing, especially difficult questions. So let's get this over with quickly. Anas, how much have you written?
I'm in the formula for step 3.
Step 3, fine. All right. Now, Manvi, I want you to read stage 1.
Yeah. Stage 1, converting sulfur into sulfur dioxide, which is S plus O2 gives SO2.
SO2, right, perfect. Now in the exam, they'll ask you, give the reactions, or they'll ask you, how do you write the reaction by which sulfur dioxide is produced. Now in all of these 4 reactions, there's only one reaction in which sulfur dioxide is produced, and that is burning sulfur in air. That's what we're doing. We're taking sulfur and reacting with oxygen. There's oxygen in the air, and that will give us sulfur dioxide. Now we don't have to react oxygen with anything because oxygen is already in the air, right?
Okay,
Oxygen
done.
is in the air. Now Anas, read stage 2.
Okay, converting sulfur dioxide into sulfur trioxide, 2SO2
Sulfur
plus
trioxide.
O2.
Okay.
Reversible
Reversible reaction.
reversible reaction, 2SO3.
2SO3. So sulfur trioxide is called SO3 because it's 3 oxide to trioxide. Tri means 3, oxide, trioxide. Now, after you get your sulfur dioxide, you have to convert this into sulfur trioxide. Now, you'll ask why? Why? Because it's a key process in getting sulfuric acid. Now, contact process is formation of sulfuric acid. And all of these steps are taken to finally get to the product. It's not a one-step reaction. It's 4 stages. Now, in the second stage, you just take the SO2 you got from burning it in air, and then you add more oxygen to it to get SO3. Now, Manvi said third stage. Read it.
Yeah. Stage 3, converting sulfur trioxide into oleum, H2S2O7. SO3 plus H2SO4 gives H2S2O7, oleum.
O7. Now, this basically, this SO3, we're adding this to H2SO4 or adding it to sulfuric acid. Now, SO3 is sulfur trioxide, and we know that sulfur trioxide, when it reacts with water, it makes sulfuric acid. Well, then why don't we react it with water directly? Why are we reacting with with this acid to make oleum? What is oleum, right? Why not we do this reaction? The other one is SO3 plus, write this in your notebook. In front of step 3, in front of stage 3, write this. Or stage 3, oleum is added to to water that produces acid mist. The reaction is SO3 plus H2O gives us H2SO4, right? That O and this 3O and this 1O becomes SO4, and this H2 gets over here. So H2SO4. Fine. Now write this down quickly. Tell me when you're done. So stage 3 has two possibilities. Either you can do that or you can do this. Let's say alternate stage 3. Now tell me when you're done writing. Volume is added. And this big chunk of rock which you can see on the screen.
Why would people go through stage 3, converting it into oleum unnecessarily when they can just put sulfur trioxide in water?
Water, right? That's the big question. They'll ask you this in the exam. Those questions are usually 3 or 2 marks. Now, have you written this in your notebook?
Yes.
Okay, Anas?
No, I'm writing stage 3 right now. The one you just showed. I'm on water.
That's all, right? You have to write both of these, not just one. So this is stage 1, 2, 3. And you can write this below. Below, alternate stage 3. So below this, write alternate stage 3. It's a possibility. Now, there's no stage 4 after this. That's it. Now, what's happening over here is that why are we adding oleum to water? Why are we not adding oleum directly to water? Man, we read this part. The last 3 words.
Okay. Water that produces acid mist.
So say that again. Produces acid mist.
Produces acid.
Now this acid mist is very dangerous. It's very toxic, and this is what it looks like. I'll show it to you. I don't think it's in this one. Perhaps it's in other notes, but I'll show it to you still. Meanwhile, what I want you to do is, unless if you're writing that, Manvi, start writing the Haber process, everything.
No, I'm done writing.
Done writing? Then write the Haber process after this. Everything from here to here. We will talk about this tomorrow. But finish writing this. Quick. Now, before you write that, look at this. Manvi, this is ananas. This is acid mist. What is this?
Acid
mist.
This H2SO4 acid mist. Now, this acid mist can destroy plants, destroy crops. It can cause you skin irritation and everything. Acid mist. And that is why we don't do this. We don't add it directly to water. In the exam, they'll ask you, why is oleum not added direct? Forget oleum, it's not oleum, sorry.
Okay.
It's SO3, sulfur trioxide. Change it in your notebook. Sulfur trioxide is added to water, which produces acid mist. Now, this acid mist is very dangerous, so we don't do that. Instead, we add it to sulfuric acid to get this thing called oleum. And then we dilute oleum by adding it to sulfuric acid. That's stage 4. I will talk about this again later. If you've written everything, finish writing this Haber process.
Okay. I'm on catalyst right now.
You're on catalyst. Good. The Haber process is not, let's say, a complicated thing. It has only one step to it, which you have to know, and the conditions are there. We look at the Haber process and the the reasons for choosing these conditions in the next class, and we'll practice a lot of questions. Then the chapter will be over. We're studying IGCSE Biology, and we're starting Biotechnology 2. In the last class, to just recap what we did, we looked at bacteria, such as yeast, and how they used to make bread, how they used to make biofuel, what are the advantages and the steps